Here we consider examples of analysis of variance for one-way classifier data. So there are three processes A, B and C, and they were tested to see whether their outputs are equivalent, and the data given as A with observations 10, 12, 13 etc., B 9, 11, 10 etc., and C 11, 10, 15 etc. The question is to carry out one-way ANOVA and draw our conclusions. So before we come to the answer of this question, we can have a look upon the various steps in a one-way ANOVA. So here the first step is to set the null hypothesis, and it is at 0 mu1 equals mu2 equals etc mu k, where mu I is the average of the ith treatment. In the present question, we treat treatment as the performance of the process A, B, Z, etc. So there are three processes. Therefore, we have to set the null hypothesis as at 0, mu1 equals, mu2 equals, mu3. So the first step is setting the null hypothesis at 0, mu1 equals, mu2 equals, mu3, where mu1, mu2, mu3 denote the average of the processes A, B, and C. So the second step is to find the correction factor C, which is given by 1 by n sigma is equal to 1 to k, or sigma j is equal to 1 to ni xij whole square. That is, it is the square of sum of entire values divided by total number of observations. In the present question, we have n is 8 plus 5 plus 6, that is 8 observations in the first row, that is 3, 2, 5, and 5 observations in second row and 6 observations in the third row. Therefore, it is 8 plus 5 plus 6, that is capital N is 19, and C is 1 by 19. Sum of the entire observations 10, 12, 13 etc. That is 10, then 12, then 13 etc. up to the last row, last value 13. So it is therefore 230 square by 19. So correction factor is 2784.21. So next is we are finding that third step, we are total sum of squares TSS. It is sigma is equal to 1 to k, j is equal to 1 to ni, xij square minus c. Here we are finding first squares of individual values and then their sum, and then subtract the correction factor. So here we are finding 10 square, 12 square, 13 square, and finally the last row, last entry 13 square minus the 2784.21. It is 2842.2781, 2784.21, which is 117.29. That is, the total sum of squares will be 117.79. Next is SST, that is sum of squares due to treatments. The sum of squares due to treatments is obtained by the row sum, ith row sum square divided by number of entries in the ith row minus c, that is xi dot square by ni sum minus c. Xi dot is sigma j is equal to 1 to ni xij, means the sum of the ith row, and its degrees of freedom is k minus 1. Therefore, the present case, the row sums are 100, 55 and 75. Therefore, that will be 100 square by this is not 10, it is 8 only. It's a correction. I can do the correction using the pencil. So this has to be considered as 8. So in the next step, we have made the correction. It is 1250, right? 10,000 by 8 is 1250. So the next is 55 square by 5 and 75 square by 6. So it is 2792.5 minus 2784.21, which is 8.29. Next is sum of squares due to errors. The sum of squares due to errors is obtained by subtracting this SST from TSS. That is, from TSS, total sum of squares, we have to subtract the sum of squares due to treatments SST, that is 109.5. Next, we find the mean sum of squares, that is by dividing those sum of squares with their respective degrees of freedom. Now expressing all these values in a two-way, in a table of one-way ANOVA. So the first row represents the sources of variation. Second row represents their respective abbreviations and the degrees of freedom. And the fourth row gives the values of the sum of squares from the data. So we can see that SST has 8.29, SSC is 10, no, sorry. After entering this SST, we have to write the total sum of squares. Making use of the row representing SST and TSS, fill up the second row, row representing error SSC, that is 16, that is 18 minus 2, 16. 117.79 minus 8.29, we get 109.5. So the order is first SST, next TSS, and making use of this, we have to compute SSC, because the first and last row we are getting from the data given. Making use of the data, we have to estimate error sum of squares. That's why we enter the SSC row after getting all these values. Next, we can come to the mean sum of squares, that is by dividing 8.29 by 2 here and 109.5 by 16 here, and that is VT, and this is VT, and this is VE, that is mean sum of squares to treatments, and the mean sum of squares due to errors, that is VE. So now VT by VE is 0.6057, and we can see that this F ratio, F follows F distribution with 2,16 degrees of freedom. The 2,16 because VT comes in the numerator and VE comes in the denominator. VT has the respective degrees of freedom 2 and V degrees of freedom 16. So in relation connecting chi-square and F, we have seen that chi-square 1 by n1 divided by chi-square 2 by n2 follows F distribution with n1 comma n2 degrees of freedom. The degrees of freedom of the numerator variable appears first. That's why n1 first and n2 second, and here that's why 2 first and 16 second. From tables of F distribution, we can get it as 5% level of significance 3.63, and the value 0.6057 computed from the data is less than 3.63. So we can accept the hypothesis and conclude that the three processes are equal in the performance of outputs. Now when we come to the second question, it deals with three fertilizers and their influence in the yield of wheat. So we have certain plots of wheat, and values of yield from all the plots are given in the table 50, 60, 60, etc. For the last row, it is again 40, 50, etc. up to 70. And in this question also, we have to set a null hypothesis that all the three fertilizers are equally effective in the yield of wheat. So that is why H0, I have not written H0 here. It is H0 mu1 equals mu2 equals mu3, and that means that all the three fertilizers are equally good in the yield of wheat. So next step is finding correction factor. It's again like finding sum of all values and its square divided by n. It is 2020 square by 30, and it is 136013.33. Next is finding total sum of squares, that is first finding squares of all these values 50 square, 60 square, etc. The last row, last entry 70 square, and it is 139650 minus 1360013.33, which is 3636.67. So sum of squares due to treatments, the next sum of squares. So it is obtained by square of ith row. It is a square of sum of ith row divided by number of entries in the ith row. Here we can see that in all entries we have say number of observations, 10 observations, and their totals are found here, that is 700, 10, 700, 720 and 600. That is sum of the first row 700. So here it is 700, and next is 620, and the next next is 620. This is 620, and the last row is 600. So we are finding the sum of squares due to treatments SST by sum of these rows divided by number of entries in each row. So 700 square by 10 plus 720 square by 10 plus 600 square by 10 minus that correction factor. You can see this is 826.67. So it is SSC means total sum of squares minus sum of squares to treatments. Now the degrees of freedom in their order 2, 4, because 3 treatments are there. So 3 minus 1, 2, 4 SST. There are 30 observations in total, 30 minus 129 for TSS. Making use of these two, we can find SSC degrees of freedom 29 minus 2, that is 27. Now the MSS are obtained by dividing the sum of squares with respective degrees of freedom. and then F ratio, entering all the values in a table of ANOVA. So the first two rows are representing the sum of squares, degrees of freedom, the third row, and this the fourth row sum of squares represents the values of these sum of squares from the data, and then mean sum of squares and F ratio. Here in F ratio, in finding F ratio, we take SST in the numerator, SSC in the denominator, that is VT by VE. So the degrees of freedom of SST appears first, and 27 the second degrees of freedom. So from tables of F distribution, we can see that the coincidence of the row, the coincidence of the degrees of freedom 2 comma 27 will be 3.35. The value computed is 3.971. So we can conclude that now we reject the hypothesis, which means that the three fertilizers are not equally performing in the yield of wheat. There is significant difference in their performance. That's about the conclusion of the ANOVA based upon the data. So, and our third question is, again a test was given to students taken at random from 5th class of 5 schools, and test whether carry out ANOVA and state your conclusions. So here the observations from five schools. We can see the page of the answer, that is the observation H0 is mu1 equals mu2 H0 is mu1 equals mu2 equals mu5. All the 5 schools are equally performing. So correction factor, sum of the entire observations, then square by 31. So it is 2130.613. Next is total sum of squares, that is 9 square, 7 square plus etc. 8 square. So minus correction factor, it is 112.387. Next is SST, that is sum of squares due to treatments. So we are finding sum of all rows here given, that is the first row 9 plus 7 plus 8 plus 10 plus 11 plus 8 plus 10, and second row and so on. We get the values are like 63, 33, 68, 39, 54. The sum of each row is given here and square and dividing by the respective entries in each row. So first school we have 7 observations, and next school we have 5 observations. The third we have 3 plus 2 plus 7, then here 6 and 6. So that's why the denominator we have 7 5 7 6 5. So that's about, and minus C is missing here. There is a correction in the answer, we are missing the correction factor, so minus C has to be taken here, and therefore I think the entire values will be changed. Anyway, it is written here, that is 2130.613 is appearing in the last step, even though not written here in all the proceedings in the previous steps. It is written in the last step, so the final answer is okay, 54.258. So yeah, here that this side the margin gives the sum of the rows also. Now next is SSC. SSC is TSS minus SST, and next the respective degrees of freedom, finding expressing all these in the ANOVA table. So we have 4 degrees of freedom because 5 minus 1, number of schools 5, number of treatments so 5, so 5 minus 1, 30 is the total number of values, minus 31 the total number of values, minus 1, 30 minus 1, 31 minus 1, that is 30. So we have 6.0669. So it is F distribution with 4 comma 26 degrees of freedom. Table value is 2.74. We reject the hypothesis, means that the performance of schools are not equal. So next we consider a case of two-way ANOVA. So here the following table gives the number of units of production per day turned out by 4 different companies. Here the right corner of this PDF file not clear. I can read the values from the page handwritten. So operators are given O1, O2, O3, O4, and their company names are given A, B, C, D, and the values are 60, 46, etc. And for the last row it is 58, 52, 49, and 48. The question is to examine whether all the operators are equally well in performing their functions. And next is all the companies are well. So here we in two-way table we consider two factors simultaneously, factor A as operator and factor B as the company. Factor A also known as the treatment, and factor B also generally known as variety. And the answer is, we are rewriting the entire values here, and we have the H0. H0 is mean production doesn't differ significantly among the four companies, and the second is efficiency of the operators do not differ with respect to the production. So we take the null hypothesis that both factors averages are equal. So we can come to the page of a two-way ANOVA, the different steps in two-way ANOVA. You can see the different steps in two-way ANOVA as yes, setting the two null hypothesis, the first step that is done already. Second step is correction factor C. C equals 1 by n sigma is equal to 1 to k, j is equal to 1 to n xij square. So here we are finding all these things. We have the total grand total 830, that is the raw total or column total 830. We have found the raw totals and column totals separately. So this is the correction factor. So we can see it as 805.75. Next is sum of squares due to treatments. So treatments is taken as here the operator effect, and therefore it is the raw totals 211, then 208, 204, 207, and squares divided by all rows have same number of values, so by 4 here minus C 6.25, degrees of freedom will be 4 minus 1 3. Now next is the sum of squares due to variety. Here variety is considered as that other thing, that is the company performance, that is factor B. So SSB, so they are column totals. So column total 226, 187, 232, 185. Their squares are here divided by 4 minus C. So it is 6.25. No, so it is for 67.25. And their degrees of freedom again 4 minus 1. So it is 3. Now, the error sum of squares are obtained by subtracting both sum of squares due to A and sum of squares due to B from total sum of squares 332.25. Now, expressing all these values in the table, we can see the first two columns representing the sources of variation and their abbreviation. And next is the degrees of freedom 3, 3. Then next we enter the last row 15, making use of the first, second, and the last. The degrees of freedom of sum of squares is obtained, and it is by subtracting 3 and 3 from 15, that is 9. And likewise the next column, the values of sum of squares from the data also computed. We write the 6.25 for 67.27 from that sum of squares due to error A and sum of squares due to B, and sum of squares due to errors is obtained by subtracting these sum of squares from, that is SSA sum and SSB, from total sum of squares 805.75. We get it as 332.25. So that's about the various sum of squares from the data. So mean sum of squares are obtained by dividing the sum of squares with their respective degrees of freedom. So VA and VB, VA is obtained as 2.08, VB is obtained as 155.75, and VE is 36.92. Now FA and FB are obtained by this ratio of this MSS. FA is VA by VE, and FB is VB by VE. So it is, we can see that in the steps of ANOVA, it is VA by VB, that is VA is SSA by the mean sum of squares, VA by VE here, and VB by VE here, that is FA and FB. Now next we have the values. The values are 2.08, no, 0.056 and 4.219. You can see the values here. For FA it is 2.08. No, it is 0.056. This is the value of FA, 0.056, that is 2.08 divided by 36.92, and FB is 4.219. It is by 155.75 divided by 36.92, and we can see the table values are 3.86, that is the coincidence of the row 3 and column 3. So it is 0.056 less than 3.86, so we accept the null hypothesis regarding factor A. Factor A means operators, and for the second null hypothesis we reject, that is 4.219 is greater than 3.86, so reject hypothesis, that is regarding the company performance. So we conclude that efficiency of the operators do not differ significantly, while mean production of the 4 companies differ significantly. Now we have the second question. Second question is to study the performance of for detergents. And 3 different water temperature levels. We have to examine whether these levels of water temperature and also the performance of the 4 detergents are significantly different. So here the columns, number of columns 4, number of rows 3. As before, we set the null hypothesis that both factors, factor A and factor B, averages are equal. Means factor A has 3 levels and average of the 3 levels are same. That is the null hypothesis 1 regarding levels of water temperature. And the second factor is detergent performance, and we assume that average performance of all these 4 detergents are same. Now we find the correction factor C, that is again as before, sum of entire values square divided by total number of observations, that is 12. So 616 square by 12, that is 31621.33. Now finding total sum of squares, just same as the steps we have done earlier. Entire observations, individual squares, total minus correction factor, it is 1122.67. And next is sum of squares due to treatments, that is the treatment is taken as factor A or the level of water temperature, and we can see that it is the rows totals 195, 205, 216, they are individual squares and divided by 4, because in each sum we have 4 entries, that's why 4, and therefore it is 55.167. Next is factor B, that is again like column totals square divided by 3 minus the correction factor 944.667. Now next is SSC, that is obtained by subtracting SSA and SSB from TSS. So expressing all these things in the ANOVA table, the first two columns represent the various sum of squares and their respective abbreviations. Degrees of freedom, SSA has 2 because there are 3 rows, 3 minus 1, treatments number 3 and 3 minus 1, and variety number 4, the 4 levels of detergent, so 4 minus 1, 3. Now the total number of observations 12, 12 minus 1 is 11. So from 11 we have to subtract, from 12 we have to subtract this 3 and 2, so it is 11. From 11 we have to subtract 3 and 2, that is 6. Or we can easily find it by multiplying these two, that is m minus 1 into n minus 1. We can see that the degrees of freedom for error sum of squares will be m minus 1 into n minus 1. So that's about the various degrees of freedom. The sum of squares we have found earlier from the data. Now mean sum of squares, they are obtained by dividing the sum of squares with respective degrees of freedom. Now finding the F ratio for factor A and F ratio for factor B. For F ratio for factor A, it is the ratio of this MSS for factor A divided by, MSS by factor A by MSS of error, that is 27.5835 divided by 20.472. So next, like that, FB, that is F ratio for the second factor, is obtained by dividing this MSS for factor B with MSS for errors, that is 314.889 by 204.472. We can get them as 1.347 and 15.381. Now the first FA has F distribution with the degrees of freedom 2 and 6, and the second has this F distribution with 3 and 6. From tables of 5% level of significance F distribution, we get it as table value as 5.14, and since this is less than 5.14, we accept the hypothesis. For the second case, we reject the hypothesis. So we conclude that the levels of temperatures, water temperatures, are not significantly different, while the other factor, that is the performance of the detergents, significantly different. So we have average performance of the detergents A, B, C, D are significantly different. So these are the examples from ANOVA.